Hello everyone, welcome back to another video on classification. So in the last video I told you that there would be more to classification. This is where we learn how to make a chart. So we already know what evolutionary trees are. These are used to show evolution, and another way of showing that is also cladograms. And basically, cladograms are very useful, especially for taxonomists, because it helps them categorize where all these things mutated and adapted from. Check my evolution video to find out more. Now, uh, if we come here, as we can see, one second. As we can see, this is a cladogram. Now, this is a bit more of a complicated cladogram, so let's just start from this point, right? So if we start from this point and we go like this, when it goes to the right, that means that this is progressing in time. It's progressing in time. Like at the earliest stage, these species evolved off the trail, and then this, and then these, and then these, and then these, and then these, and then these. And you see these points between these are mutations. And mutations are very important to be shown in cladograms. Now, let's take an example of this. It started with amniota, which is basically just a type of animal or a very vast category of animals. And as they went up, right, and as they went, for this one, going left is the right, so let's just completely ignore this part. When we're going this way, we're evolving. And these are all branches of like one species. Like dinosaurs, all of these evolved from either each other, like this, or they evolved from one common ancestor. So just like I told you in my evolution video. So just to take a recap, when we're going right, that is a thing of time. That is saying of time. And these, whenever we're going this means that there was a branch off, meaning that there's a new species created. And these marks are usually mutations, but I don't know what they've done in this picture. But usually they're mutations. Now, let's make a cladogram ourselves. So I'm gonna go humans because humans are the best creatures ever, and we're going to go like this. This is an accurate flow of time. Now, this is what a cladogram would be if there were absolutely no evolutions, no mutations, no nothing. Now, let's add let's add a creature. All right. So let's name this Homo. Right? But of course, to make something evolve, you have to adapt, and to make an adaptation, you have to have a mutation. So for mutation, we'll put a box, okay? So box as mutation, okay? So this was a mutation along the way. Here is another mutation. Let's name these guys chimps. Let's name these guys chimps. All right? Chimps, right? And then it keeps on going on and on and on and on until you reach like the last creature in this bucket of creatures, which is us. So yeah, and another thing is usually, I'm saying usually the ones at the end, at the very most end, die out before these guys. So these guys died out before these guys. Of course, this is accurate. Humans did not die out before chimps. This isn't wrong. This is just an example. These guys died out before these guys, and then these guys died out before these guys, and then these guys died out before these guys. And then usually, this is what it would look like at the end if there are multiple species living at the same time. This is what it will look like. Or maybe not that. Maybe something like, maybe it would be sorry, that's not correct. It would be like this, which would be like whatever. So let's just name this 1, and then it would be like this, which is named 2. Do not confuse this part for the entire cladogram. All right. So that is how to make a cladogram and understand a cladograms. They were pretty easy, I hope. I hope wonderful day. I hope you understood this entire topic, and please subscribe as it helps me. Um, and please don't fail your test. And yeah, I hope you had a good time.